a concept called percent yield. What do you think percent yield means, right? Just based on its title, what do you think percent yield might have to do with? Does our yield match what our expected yield is? That's what percent yield is. Okay, does what we actually make, does it match what we expected? So far, we've been doing what's called theoretical yield. We've been calculating the theoretical yield. Okay, so far we've been calculating theoretical yield, which means we've run a t-chart, and that means our math is fine. We're assuming that everything in the reaction goes exactly as it should. That's theoretical. But the actual yield maybe doesn't necessarily happen that way. When I go back and I do the lab, maybe I don't get all of my contents transferred into my experiment vessel. Maybe I have minerals or something impurities in my water that I'm using that adds to my yield. There could be something that makes my actual yield different than my expected yield. And so that's what we're really looking at here. We're just finding the comparison of what should it have been versus what it was. Okay, so it's just, again, like calculating percent, almost like percent composition, right? You're calculating what it should have been versus what it was, okay? So we're looking at ratio of, I use this equation right here. Percent yield is equal to the actual over the theoretical, okay? Actual over theoretical. All right, and to put it in a percentage, we take that decimal and we multiply it by 100, right? Because when we take that value, we're going to get a point something. We got to take it times 100 to get it into a percentage. The theoretical yield always comes from our t-chart. Okay, theoretical comes from the t-chart because it's what should have happened. The actual yield might come from the lab, right? Or given to you in the problem or something that we solve for or whatever it might be. But the theoretical yield always comes from the t-chart. Okay, so T and T. Actual yield might be given, but it would be what we actually do in the lab, right? It's what actually happened. So you have to be really careful about reading context clues in these problems. It might say this much was produced, right? That would be our actual yield. And then we'll have to go find our theoretical from the t-chart. Actual and theoretical yields. All right, let's try this one here. It says, how many grams of water will be formed if 36.5 grams of oxygen are used? And then what is the percent yield if only 7.95 grams are formed? So,
is this like, is it also just like a what if?
Yeah. I mean, we're calculating hypotheticals here, right? So this is my starting amount, 36.5 grams of oxygen, 36.5 grams of O2. How many grams of water will be produced? And it says this is 7.95 grams are formed. What does that value tell me? What's the 7.95 going to be? That's my actual yield. So I'm going to hold on to that for a little bit because if my goal is to find the percent yield, I'm given the actual yield. What do I still need? I need the theoretical, which has to come from a t-chart. Okay, so I'm going to come up here and figure out what's my theoretical yield of H2O. Right? What is my theoretical yield of water? So I do that with a t-chart up here. 36.5 grams of oxygen. Grams to moles. What's my next step here? Moles of oxygen to moles of water. Good. And then we'll go moles of water to grams of water. Okay. We're going to go ahead and fill in our numbers here. Where do these values come from right here? They come right from our balanced equation. That's our mole ratio step. So it comes right from our balanced equation. Then we're back to 1 and our molar mass. We feel comfortable with that t-chart coming together? And we think we do that by ourselves? I hope. But I'm happy to answer questions about them if we have them. So I got a theoretical yield of about 10.26, 10.27, somewhere around there. grams of H2O. Would we agree with that for our theoretical yield? This is my theoretical yield, and so it's going to come down here into my equation. So I'll say the percent yield is 7.95 divided by 10.27. That's going to give me a decimal of some sort. And so that gives me about 77% yield.
Is this all this is?
That's it. Okay, try this one on your own. It tells me the starting amount and it tells me the percent yield. It wants to know how many grams of H2O will be produced. Do you think it wants the theoretical yield of H2O or the actual yield? Final answer, we want to be the actual because it gives me a percent, right? So I want to know the actual yield of H2O. Okay, so let's go ahead and try that. I think it already is balanced, yes. Good. This reaction is decomposition because we're taking something and breaking it down. The opposite of that would be a synthesis reaction, which builds it up. Okay? So this says 20.7 grams of calcium carbonate produces 6.81 grams of calcium oxide. What is the percent yield? So this, it says it produces 6.81. Is that our theoretical or our actual yield? Actual, right? I know I told you right there, but it's our actual yield. Can we figure that out via context clues? Okay, so we have to calculate the theoretical yield, so we need to find out calcium oxide. That's the number of grams we're looking for. Okay, the number of grams of calcium oxide. So 20.7 grams of calcium carbonate.
Okay, ready. Alright, ready? Yeah, so just 592, you mean?
It's grams of calcium oxide.
Grams of CaO. Now I'm looking to find my percent yield, so I'll take actual divided by theoretical.
We're looking for a percent.
No.
So that gives me 58.7%, roughly.